1,158 tool calls, 0 humans. 35 hours straight. One AI optimized a chip it had never seen before. On May 20th, Alibaba launched Qwen 3.7 Max at the Apsara Cloud Summit. But the central proof point of this release wasn't some standard benchmark score. It was a 35-hour continuous run. This execution sets a hard baseline for long-horizon agentic capability. It proves an AI model can operate autonomously over an extended time frame to solve a highly specific, complex engineering problem.
The parameters for this blind task were pretty severe. According to the official Qwen blog, VentureBeat, and reporting from Jigazine, the model was handed a very specific target: optimize the SGLang Extend Attention Kernel. The hardware environment was an Alibaba-designed T-Head ZW-M890 PPU. And here's the catch. The model had literally never seen this chip during his training phase. It was provided 0 hardware documentation, no prior profiling data, and no sample kernels to assist its optimization. The AI was basically dropped into an empty workspace with just a task description, the existing software implementation, and an evaluation script. It had to figure out the hardware architecture completely through trial and error.
Over the next 35 hours, Qwen 3.7 Max executed the task autonomously. It wrote code, compiled it, profiled the performance, and iteratively improved the design. It actually diagnosed its own compilation failures and fixed its own correctness bugs. 1,158 distinct tool calls, 432 separate kernel evaluations. Just by running runtime profiling, it identified performance bottlenecks and completed 5 distinct architectural redesigns without any human intervention. Around the 2-hour mark, it initiated a split KV redesign because the initial kernel was leaving most streaming multiprocessors idle. By hour 3, it moved to workload adaptive tuning. Fast forward to hour 25, and it's implementing advanced reduction and batching optimizations. It continued finding meaningful improvements past the 30-hour mark, ultimately arriving at an MTP-specialized kernel that processed multiple queries simultaneously. It maintained a coherent optimization strategy the entire time without losing context or regressing.
The output was a 10 by geometric mean speedup over the reference Triton implementation. But we need some context here. As explicitly noted by Tech Times, these are Alibaba reported figures. Right now, there has been no third-party reproduction of this exact run. An independent reproduction of a 35-hour hardware optimization task is incredibly difficult and will take time. However, the exact performance multiple is secondary to the operational reality. An AI model successfully managed a multi-day software engineering loop on undocumented silicon. If you're a product manager or founder, the core implication here is immediate. The fundamental unit of AI agent work has scaled. Previously, AI utility was measured by the 5-minute answer. You prompt a model, you review the text, you iterate. Well, that paradigm is ending. The new baseline is weekend-long autonomous execution. If an agent can maintain context and actively problem-solve for 35 hours straight, traditional software development sprint plans are outdated. The distinction between a copilot and an agent is now measurable in days of continuous compute. You are no longer managing a tool that simply speeds up human typing. You are managing an autonomous system capable of executing multi-day engineering tasks in the background. While your human team sleeps, the agent tests, fails, and rewrites its own logic. Your resource allocation models, your sprint planning, and your expectation of output velocity must adapt to this shift.
The unit of AI work has shifted from a 5-minute query to a weekend-long execution cycle, requiring an immediate restructuring of how we plan and assign engineering tasks.